Hello everyone, welcome back. In this video, we are going to look at problem B from Educational Codeforces Round 140 Div 2. The name of the problem is block towers. So according to the problem statement, we will be given n block of towers, n block towers numbered from 1 to n. And the ith tower consists of AI blocks. And each block, we can assume that each block is of height 1 unit and ith tower consists of AI blocks. It is given that in one move we can move one block from tower I to tower J only if the height of tower I is strictly greater than the height of tower J. Then we can move one block from tower I to tower J. So after this move, after performing this move once, the height of tower J will increase by 1 and the height of tower I will decrease by 1 because we transferred one block from tower I to tower J. So we can perform these moves as many times as possible as we want. Our goal is to find the largest number of blocks that we can have on tower on the first tower on tower 1. Okay, after performing these moves. So this was the problem statement. In the input, we'll be given the number of test cases, and in each test case, in the first line, we'll be given the size of the array which will be given to us, which represents the number of towers. In the second line, we'll be given n space separated integers representing the elements of the array, and each element represent the height of the ith tower. Okay, so and we need to output the largest number of blocks that we can have on tower 1 after performing some operations on after performing some number of operations. So this was the entire problem statement. Now let us see the approach to solve this problem. So the operation or the move that we can perform is that uh, firstly our goal in this problem is to maximize the number of blocks in tower in tower 1. Okay, so our goal is to maximize the number of blocks in tower 1. So this is our goal. We need to maximize the number of blocks in tower 1, and for that we can perform some operations. In each operation, what we can do is we can select two towers, and let's say the height of the two towers is AI and AJ. So if the height of tower I, which is AI, is strictly greater than the height of tower J, then we can transfer the blocks to tower J unless the height of tower J becomes greater than or equal to height of tower I. So this is the operation which is defined in the problem statement. Okay, so now we need to find out a logic or a way to do this, to perform these moves such that the number of blocks in tower 1 is maximized. So if we look at this operation, uh, so let us consider that the height of the first tower is 3 here, and and we are taking some other tower which has height 6. As the height of the other tower is strictly greater than the height of the first tower, it means that we can perform the operation on these two towers. So we will, on performing the operation once, the height of the first tower will get increased by 1 and it will become 4, and the height of the other tower will get reduced by 1. So now the height of the two towers is 4 and 5. Now as the height of the first tower is strict is now as the height of the first tower is still less than the height of the other tower, it means that we can again perform this operation. So on performing this operation again, the new height will be 5 and 4. So now, as you can see, the height of the first tower is now strictly greater than the height of the other tower. It means that we can no longer perform this operation on this particular tower. Now we will look for some other tower which has height greater than this new updated height of tower 1. Okay, so now in order to solve this problem, what we are going to do is that we will firstly keep aside the height of the first tower, and we need to maximize the number of blocks in tower 1. Now we are now for the remaining heights of the remaining towers, we are going to sort those heights. So for example, in this example, we have taken the height of the first tower. We are going to sort the heights of all the remaining towers in ascending order. And uh, after sorting the heights of all the remaining towers, one by one, we are going to iterate through all the other towers after sorting their height, after sorting them according to their heights. And one by one, we are going to check how many blocks we can transfer from that particular tower to tower 1. Okay. If the height of tower 1 is already greater than or equal to the height of other tower. Okay, so if the height of tower 1 is already greater than or equal to the height of the other tower which we are considering, then it means that we cannot perform this operation and we cannot transfer any number of blocks to tower 1. Hence we can continue, but here we cannot perform the operation. But else, if the height of tower 1 is less than the height of the other tower which we are considering, then we will perform this operation, and we are going to find out what is the maximum number of blocks that we can transfer to tower 1. Now here we saw that how we were transferring the blocks one by one, but in our code we are not going to do this uh, in brute force fashion. Why? Because it will not be optimal for us. So we'll be using this formula. Basically, this formula will give us the updated height of our tower 1. So the formula is height of tower 1 plus height of the greater tower which we are considering, and we are dividing their sum by 2. So for example, here the height of first tower was 3 and other height was 6. So if we do 3 plus 6, it gives us 9, and if we divide 9 by 2, so here we are considering seal division, which means if after dividing we are getting 5.5, we are going to consider 6. So 9 by 2 seal division gives us 4.5, which so we are going to consider 5. So as you can see, with this formula we can get the updated height of tower 1. So whenever the height of tower 1 is strictly less than the height of the other tower, we are going to apply this formula and we are going to find the updated height of tower 1. And before doing this, uh, we'll be first sorting the heights of the remaining towers. So here after sorting, it will be 1, 2, 6 and 10. So why we need to sort them? Because if we directly or randomly perform this operation, so let's say if instead of performing the operation in ascending order or in the increasing order one by one, if I directly perform the operation on the first tower and the tower with the greatest height, let's say I'm performing the operation with tower with height 10, then the height of the first tower will surely increase, but then why there is a need to sort the heights of the remaining other towers? Because let us consider this test case. If the height of the first tower is 3 and the height of the other tower is 9, and we start performing this given operation, so the updated height after performing this operation the updated height of the first tower will be 6. Okay, so we will be performing this operation as long as the height of the first tower is less than the height of the other tower. So after performing this operation, we will end up with heights 6, 6. Now as both the heights are equal, we cannot perform this operation again. Now let us say we are considering some other tower which has height 6. Now as the updated height is 6, we cannot perform any operation with this tower which has a height 6, because we first considered the tower with greater height. Okay, so as you can see here, we cannot transfer any number of blocks to this updated tower 1 height. But if instead of first considering the tower with height 9, if we perform these operations on the tower with smaller height, so if we consider the tower with height 6 and we start performing this operation, our updated height will become 5. Okay, so now we can again perform this operation with other tower which has height 9. So I hope it makes sense. It is always optimal to sort the height of the remaining towers, and one by one in the increasing order we check each tower that whether we can perform the operations with that tower or not. So this is the approach to solve this problem. So now let us see the code and it will be more clear. This is the code. So firstly we are taking the input. So n is the number of towers, and in the next line we are inputting the array where each element represents the height or number of blocks in the ith tower. Then we have initialized our answer variable, which will be initially the height of the first tower, and then we are sorting the all heights of the all the remaining towers starting from the second tower, and we are sorting them in ascending order. As we already discussed, it is always optimal to move in increasing order, and one by one now we will iterate through the sorted heights, and one by one we are going to check if it is possible to perform the operation. So if the height of the tower is less than or equal to the current height of the first tower, it means we cannot perform the operation and we will continue. But otherwise, if the height of the tower is greater than the current height of the first tower, it means we can perform the operation here, and we can perform the operation. And we are going to calculate the updated height as we already discussed. This was the formula to find the updated height of the first tower. And after traversing through all the heights of the towers, we are going to print our answer. And if I run this, as you can see, all the test cases were passed. And let's try to submit this. So this should get accepted. So as you can see, this solution got accepted. So this was the approach to solve this problem, and I hope it was clear. Thank you.